This is Kirti Sri. I'm pursuing BTech second year in VVIT University. Today my topic is about moments. Moments. A moment is a numerical measure used to describe certain properties of a probability distribution, which means we also known as a probability distribution as a random variable. They give information about the shape, spread, and location of the distribution. Think of moments as statistical fingerprints, which means they summarize how data is distributed in a graph. Why do we study about moments? We study moments because they summarize important features of random variable. It means how the random variable is dispersed or shape, etc. It describes about central tendency. It means the average behavior of random variable. It describes about spread or dispersion. It graph how it dispersed or it compressed, etc. It means how data varies. It describes about shape like symmetry, skewness, peakedness, etc. It provides mathematical tool to compare two different distributions. We can't compare two different random variables directly, so we use moments to compare it for to compare distributions. Two types of moments for a function of random variable x. First one is moment about the origin. Second one, moment about the mean. It is also known as central moments. First, we will discuss about the moments about the origin. Let us take z of x be a real function of random variable x, such that z of x is equals to x power n, for n is equals to 0, 1, 2, 3, we taken as whole numbers. Here, as we taken z of x is known as moment about the origin of a random variable x. It is denoted as small m suffix small n, where n indicates the order of the moment. Mathematically, nth moment is defined as m suffix small n is equals to expectation of x power n. Here x is taken as random variable. Expectation of x power n is equals to minus infinity to infinity x power n fx of x dx. Here fx of x dx is probability density function. For a discrete random variable, we take moments about the origin is expectation of x power n is equals to summation of xi x suffix small I power n into p of xi. First, we will describe an expression for probability density function. If we take order of n suffix n is equals to 0, m suffix n we take in. So m naught is equals to minus infinity to infinity x power 0 fx of x dx is equals to 1. It means we taken m0 as that 0th moment. m0 is equals to 1 gives the area under the PDF. So as we done for n is equals to 0 expression, now we will find out the expression for n is equals to 1, 2. If n is equals to 1, m suffix 1 gives integral minus infinity to infinity x f of x into dx is equals to expectation of x. Means in the first moment, the the first moment is equals to the mean value. m1 is equals to x bar. We say that. If n is equals to 2, then we conclude that m2 is equals to minus infinity to infinity x square fx of x dx is equals to expectation of x square. Means the second moment represents the mean square of x. Here as we done x is for first moment it is equals to the mean value, and for the second moment it is equals to the square value of x. If x is a random signal, m1 gives the average value and average value of the signal, and root m2 gives the RMS value of the signal. We completed the expressions for moment about the origin. Now we conclude the expressions for moment about the mean. It is also known as central moments. Let g of x be a real function of a random variable x, such that g of x is be taken as x minus x bar whole power n for n is equals to 0, 1, 2, 3, etc. taken as whole numbers, where x bar is the mean of the x. As we taken m1 is mean, so x bar is the mean of the x. The expected value of function g of x is called moment about the mean. of a random variable x. It is denoted as nu suffix small n, where n indicates the order of the moment. These are also called as central moments of the random variable x. The general formula for moment about the mean is given as mu suffix n is equals to expectation of x minus x bar whole power n, which is equals to integral minus infinity to infinity x minus x bar whole power n into fx of x dx. As we see, the before equation is for continuous random variable, and here for discrete random variable the formula is given as nu n is equals to sigma x suffix small a minus x bar, which means to mean, whole power n into probability p of xi. This is the equation for discrete random variable. Case 1. We take in for 3 cases for moment about the origin. Same as here, moment about the mean also we take in 3 cases. Case 1. When n is equals to 0. N is equals to 0 means order. Nu 0 is equals to expectation of x minus x bar whole power 0. It means integral minus infinity to infinity x minus x bar whole power 0 into fx of x dx. For anything power 0 is the value equals to 1. Since so that mu naught is equals to minus infinity to infinity, here x minus x bar whole power 0 is equals to 1. So finally we taken that minus infinity to infinity fx of x dx. Here it is denoted as total area under the probability density function, which is always equals to 1. Finally, we get that nu naught value is 1. This means the zeroth central moment is always equals to 1. When n is equals to 1 means when order equals to 1. U1 is equals to expectation of x minus x bar, which equals to minus infinity into x minus x bar whole power 1 into fx of x dx. Here by expanding the equation means by expanding the minus in between of them, we get that integral minus infinity to infinity x fx of x dx minus x bar into integral minus infinity to infinity fx of x dx. Here x bar is constant, so that we taken out from the integration. Here the first term minus integral to integrity fx of x dx is known as mean, definition of mean. Here the second term is as we know that the area of this function is known as 1, so that the value is 1. X bar, mean into 1 is equals to x bar. Here finally we get that nu1 is equals to x bar minus x bar equals to 0. Then after, the first central moment is always equals to 0, whereas the zeroth central moment is always equals to 1. Now we can conclude that about central moments. Why these central moments are used? Means why are these? So they use it to measure the deviation of random variable x from its mean x bar. Means how the random variable x is deviated from the mean value x bar. For example, here the variance. Variance means we know that second central moment tells us how spread the values are about the mean. It means how the values of variance is spread around the mean, about the mean. Here, next, importance of different central moments. As we before concluded that u0 means zeroth central moment is 1, which means confirm the area under a PDF is 1. As we also confirm that u1 is equals to 1, first central moment, shows the deviation from the mean, cancel out. Means what is means balance property of mean. Nu2, variance and measures dispersions. Nu3 is the skewness and measures asymmetry of distribution. Symmetry means as we cut a graph into two halves, the left part and right parts need to be equal. Here it shows that asymmetry means the left part and right part doesn't equals to each other. Nu4, kurtois measured spikenets or planets. It means how the graph shows me for nu4. Now let us discuss about discrete and continuous. Discrete versus continuous. As we saw before the expressions for central moments, we have common point of continuous distributions is integrals, means continuous distribution use integrals with period of x of x. As for discrete distributions, the summation are common with probabilities p of xi. So this is my topic about moments. Thank you. Finally, this is my seminar topic about moments, which is done by Kirti Sri from VVIT University. Thanks to everyone.